Every device you own, your phone, your car, your laptop, every single thing runs on chips. Tiny pieces of silicon that have to be cut, sealed, tested before they reach to you so that they don't melt in this sweltering heat and they don't catch fire. But ever wondered where does all of this entire magic happen? It happens at places like these. You can see behind me the Kaynes Semicon industry, the Kaynes Semicon facility in Sanand, Gujarat. And I'm here to report on what the facilities look like from inside. What do these clean rooms look like? What actually goes in places like these? I'm in Sanand, 30 kilometers from Ahmedabad, and this is where India is trying to write its semiconductor story. Three facilities are doing what's called outsourced semiconductor assembly and testing, OSAT, the final stage where chip gets packed and tested for your devices. Micron, CG Semi, and Kaynes. I'm here at Kaynes. PM Modi has inaugurated a few of these facilities personally, but these facilities aren't making chips from scratch. The silicon still comes from Taiwan or China or South Korea. But what happens here is the finishing. So, is India actually building the semiconductor industry, or is it just the world's fancy packager? I'm here to tell you guys about that. I'm Brinda Tulsian in Sanand. You are watching The Print. Hi everyone. So today we are at the Kaynes facility that is largely handled by the freshers in various processes. So these are really technical processes that is now engaging freshers from various parts of the world who have come to Sanand at the Kaynes facility, and to explain these really complicated processes, because I'm pretty sure that a lot of you like me have no idea about what goes on in these big white rooms. We have with us Suman, one of the freshers who is working at Kaynes, who is going to explain what happens in the first room.
This is the first process where we check all the incoming raw material like wafer, lead frame, or solder paste like that. And after inspection, we keep our particular separate desiccator. Whatever need to into like into cabinet, we put our all wafer for into cabinet. We keep our all wafer. Either that for oxidation will happen for the this we need to keep inside. And with this we also here check all in process monitoring by that HTM7 and measuring all these things.
So, what does your day look like? When do you start off? What do you do when you come here? Is it the same process every single day?
No, not like that, not same process. Whatever like going on like in process, like I as an example I am saying like die attach happening or wire bonding happening. So like after die attach we need to check here their BLT is their ball line thickness, and we need to clarify either that thing spec or meet our specification. What if our actual specification either that things are meet or not, we at first need to check. If that specification will meet, then after we clarify to them that that is okay, you can run that next process, like we can achieve this thing.
Walking into the Kaynes Semicon production floor is unlike entering any factory you have seen before. Before you cross the threshold, you are handed a white anti static gown, a cap, and shoe covers. You press your palm against a metal grounding plate at the door to discharge any static electricity your body has built up, because static at the level generated by simply walking across a floor can permanently destroy a chip worth hundreds of dollars. Inside, the air is filtered and pressure controlled. The temperature is a steady 20 degrees, even on a day when it is pushing 47 outside. The floor is divided into cleanliness zones measured by the number of airborne particles allowed per cubic foot. In the most controlled zone, a speck of dust invisible to the naked eye is large enough to ruin a chip. What happens inside runs through 7 to 8 steps. A silicon wafer, roughly the size of a dinner plate, thinner than a fingernail, arrives from a fabrication plant abroad, carrying hundreds of microscopic circuits already etched into its surface. Each circuit is one chip. From here, it gets cut into individual chips, each one mounted onto a metal frame connected to the outside world through wires thinner than a human hair, encased in a hard protective shell, and then tested, every single one, not a sample, before it ships. The chip that comes out the other end of this process is the one that you will eventually go into your air conditioner, your washing machine, your electric vehicle. For the first time, it will be packaged and tested in India. So now we are at the second process in the facility, and we have with us Tanya, who is really going hard at work, but we are here to disturb her, and she is going to explain us the second process. Tanya, could you explain to us what you were just doing?
Actually, after IQC, we come to wafer mounting. In wafer mounting, we mount tapes on wafer. There are two types of tapes we are using, UV and non-UV. And after mounting, we go for dicing process. So let's. So in dicing process, the wafer that is came after mounting, we cut it into individual dies which we use for further processes. So this is very critical thing, because if a single die is missed, it will have a long impact on further processes. So this is whole the process of wafer mount and wafer dicing, and after that this will go to die attach.
What did you learn to come at Kaynes and then do something like this? What goes in education, and how did you come to Kaynes? Why did you think that you want to work in an OSAT facility?
Like from my education, I am an EC engineer, electronics and communication. So in that, at that time, I get to know that there are coming many OSAT industries, and because of Kaynes only, I have came here. They have given a course of 10 weeks in which we have learnt what the OSAT is, and after going through that whole course, we get to know that it is a good opportunity for a fresher to be here in Kaynes Semicon.
We have now reached at the last and one of the most crucial processes that brings together the entire OSAT chain. It's a testing part of it. We have with us Mr. Ravi, all the way. He's working here and he's come here from Malaysia, and he's a testing head here. He is going to explain to us what exactly is the testing, what goes behind it, and why is it so important to keep so many of our devices, from our laptops to refrigerators, running in the heat, running all throughout the day.
Okay, good morning everyone. I'm Ravi Sagadavan. I'm basically managing the entire test manufacturing operation. Okay, basically test is one of the very critical process in semiconductor industry, where we test, we will ensure the good quality product shipped to the end customer. Let's imagine if any of the defective parts go into an end consumer's application, that product cannot be used, and it also not good for the the company image and entire semiconductor world. Okay, let me briefly explain how our process are going on in a test. Okay, basically test is a last process in a semiconductor. We will be receiving the material, singulated material from assembly, and we will be using test handler and also testers at the back for testing purpose. Okay, test handler and tester is has to go in a pair, because I just give you one simple example. Okay, our human body, brain is the main controller, and the brain will give the signal to entire body, and the body will react accordingly. Okay, same concept in use in testing manufacturing. We have a tester and handler. The tester will be loaded with the test program, and the test program will give the signal to the handler whether the units are assembled and processed according to the requirement. So the test handler will be sorting out the unit based on the limit being set in the test program. So those reject will be screened out. Those not meeting the criteria will be screened out as a reject, and those meeting the criteria will be screened out as a good product. And the good product will go into the packaging like a tape and rail, tube out and tray out. And final packaging, we will do it in we will put in packing boxes and wrap it according to the customer requirement based on their MSL criteria. MSL means is a moisture sensitive level where the products, those baked product require MSL3 and a non-baked product is a normal packing. So MSL3 product will be vacuum sealed and desiccants, and we will put one HIC indicator to ensure the products are good at all the times.
PM Modi came here to inaugurate the Kaynes OSAT facility on March 31st, and it was a big moment. But sir, beyond all of that, beyond the fanfare, what do you think happened on that day in terms of the semiconductor dreams and the vision of India?
So first of all, thank you. Thank you for having me to chat up with you. I will not call it as a fanfare. What followed was all the social media posts on LinkedIn, Insta and all the print that carried this. It was basically a hard work for the last 3 years, exactly 3 years. We started somewhere, this company was formed in April, May of 2023. From there to the journey here, you can see the Unit 1 started production, Unit 2 coming up almost 80%, Unit 3 already conceived, and a whole set of customers, 22 set of customers lined up. The hiring that has happened, the capex that is invested, the management support that we have got, the various kind of teams that we have put together in place, be it operation, assembly, test, reliability. The only one of its kind in India, under the Semicon umbrella of Kaynes Group, we're the only one in India to have a one-stop solution for R&D, OSAT, reliability and FA, failure analysis, ATE, which is post-silicon engineering, system solution group and ODM.
Sir, but a lot of people confuse as to what is an OSAT facility, what is semiconductor producing facilities, because to a layman all these are really confusing terms. So firstly, can you explain what exactly happens here? And since it's different than producing semiconductor chips, so we are technically still, doing a lot of packaging and testing for semiconductor chips coming from outside. So what's the plan in the future? Where is India headed towards producing its own chips, especially in the times of global conflict, in the times of where we see that all these supply chains are very precarious?
So, just to not talk whether we missed the bus or we are catching up and all that stuff. There are 4 segments when we look at semiconductor. One is design, second is fabrication, third is OSAT, which is assembly, test and packaging, and fourth is a EMS, where this chip goes and sits on the board. It is PCBA done and given to the customer. So out of these 4 processes, chip design, India has been doing for the last 30 years. We are second to none. 30% of the world chip designers are from India. 20% of the components of a chip get designed over here. So that is done and dusted. Chip design is prevalent in India for the last 30-35 years. What is happening there is that we are designing chips for the multinationals. There is Qualcomm in India, there is Intel in India, there is AMD in India. All our engineers are designing chips for them. IP is not in India. So that is one problem. But having said that, expertise exists. There is a fab in India called Semiconductor Complex Limited in Chandigarh, but that's a small boutique fab. Now the government is looking at upgrading that fab to be an R&D fab. Government has already approved Tata to put a fab in Dhulera. So that is taken care of. Now fab is a huge capex intensive. Government is trying to bring in fab, in the gallium arsenide, on the silicon carbide and all that, but that will come in ISM 2.0 budget. In the 1.0 budget, they took care of a fab. This will start to production in 28 and 29 kind of a time frame, which means that we have started to look at it. Along with that is OSAT. After the fab, what happens is that when you design a chip, there is a database that comes after the design, after it goes through the entire process. This database is given to a fab. This fab takes the database, comes out with a wafer. That wafer comes to OSAT. We get the wafers from multinational. Then we will cut, slice, assemble, package, test. Here is where the semiconductor comes out, the end package product, which goes to a EMS or PCBA, which means that this OSAT is a large manufacturing opportunity. For one fab, there can be a 4 or 5 OSAT, which means that this is also capex intensive, but less capex intensive than a fab. That's why to put a OSAT was the easiest thing to do. And hence, you see 10 OSATs the government has looked into, multiple areas, right? So we are looking at OSAT in the power domain. Somebody else across the road is looking at in the microcontroller domain. Another OSAT, which is an ATMP, Micron, is doing memory. There are some OSAT for silicon carbide. There is a glass substrate guys in Odisha. There is CDIL in Chandigarh and all of that, which is all the need of the hour.
Just on a lighter note, I mean, you guys are coming from all over the country, all over the globe as well. So, how does life look like in Sanand, Gujarat, especially in this kind of, weather environment and the kind of industrial area that you guys are living in?
He is from Philippines and he is from Malaysia. So perhaps.
And you as well. I mean, you must not be from Gujarat itself.
Yeah, I'm from
right?
actually Chennai.
So, that's quite a huge cultural jump.
But it is better to listen from them.
So I think we are more of focused on the technical, manufacturing and operation. So to us, it's not a big deal because we come from where we stay. Then we just go to the factory and then we just work on it. And there are so many things to do actually. So by the time we finish our work, it's very late in the evening. So on weekend also we are here actually right now on weekend. So I think you are right. I think how we manage it is because we have been used to doing this. So it's not really much concern. But I think those people, even from India, from the south, they come to the north, they have to adapt the whole thing. Yeah, there are some challenges that we need to manage, but it's not really that bad. You can survive.
No, actually we have to add one point here because, Gujarat, obviously you know that it's a dry state. When we want to host to our customers and or the vendors, so something is lagging here, which we have already highlighted this to the government knowledge because that kind of thing is needed for any business. So because Gujarat, there are 2 states in India, they doesn't have allow the alcohol here, right? One is Gujarat and Bihar. But anyway, Gujarat is an industrial hub where this is one of the important thing which we have already highlighted. Let's see whether the government will consider that.
But we are okay. We don't drink.
Yeah, we are okay.
Most of the
I think you touched a very good question. Of all what Paul told us a while ago about the equipment, the materials, and all those things that we need from that we are doing on the quality side, on the process side, the human capital is really very important. Now, there are 3 things that we're currently doing, which is leveraging from our customer technology, which we have partners and customers that are giving us technology as well. Second is leveraging from our partner, meaning vendors. There are equipment vendors who are giving us training. And that is an in-depth training that we currently have. And third is we're using experts, the type of Asni, who came from Malaysia, an expert on product and tests. Paul, also from Chennai, and he's an expert as far as the whole assembly is manufacturing. And there are also people that we recruited from outside, and we are leveraging from this expert. And the fourth one is how we cross-pollinate. We cross-pollinate from whatever is the local and whatever is the foreigner, that international that we are currently bringing. And the last one is the fresher. We run for at least a year of online. That is introducing all the processes from start to finish. And then we recruit them. There are at least 11 now in the line that is currently going an in-depth training. and they're the one actually in some cases explaining to our customers, to our partners. So they're, I would say, from level 1 to 10, they are now level 2 to 3. So it's beginning to hone the people that we have here. Now, as far as the human capital, there are two things that we need to understand is for example, the software. When we talk about the software, this is about the heart and the mind, which the people has, right? Meaning all these pressures, they are really very assertive. And they want to learn, they want to face the customer, they want to face PM Modi, how they learn from Keynes. And obviously, the software, the hardware is what we are trying to address.
200 meters from Kaynes is the second facility ThePrint visited, CG Semi, a joint venture between India's CG Power Group and Japan's Renesas Electronics. The same protocol applies: gown, cap, grounding plate. But the workforce here looks completely different. Every single operator on this floor is a woman, 100%. Most of them have come from tribal areas of Chhattisgarh and Jharkhand, many of them away from their villages for the first time in their lives. Before going on the floor, they were sent to Renaissance manufacturing facility in Malaysia for 3 months of hands-on training. They came back and ran the machines independently. Renesas recently conducted a full quality audit of this facility. In the global semiconductor industry, 80% is considered a good score. CG Semi scored 92, better than many long established facilities across Southeast Asia. Every machine here is a global best in class for its category. The backup power system runs on magnetic levitation, the same principle behind bullet trains, floating on magnetic force rather than mechanical contact, making it more stable and less power hungry than conventional systems. The entire 2000 hectare Sanand GIDC estate, stretching across a 90-kilometer perimeter, is monitored from a single room called the Command and Control Center. 9 CCTV surveillance points cover the estate. Smart water meters on every industrial plot send real-time alerts the moment any company's consumption crosses its permissible limit. Company complaints arrive on a WhatsApp group and are reviewed every week. The range of those complaints is wider than you might expect. During last year's monsoon season, Micron Technology complained about a mosquito problem at the facility directly to the Prime Minister's office. It is, the GIDC official told ThePrint without evident irony, the kind of thing they also have to handle. Not everyone in the villages surrounding the cluster is satisfied with what the industrial transformation has brought. Residents ThePrint spoke to, who spoke in Gujarati with responses later translated, said the water in the area has become noticeably harder since industries came in, a problem that has worsened since Micron, one of the highest water consumers in the cluster, became operational. Semiconductor manufacturing requires vast quantities of ultra pure water processed through multiple filtration and chemical treatment stages, and this large scale extraction can raise the mineral content of groundwater in surrounding areas, affecting taste and daily use. The GIDC maintains the cluster draws from a separately allocated supply that does not touch the village's drinking water. The question of quality as opposed to quantity remains unresolved. Boal village, which borders the cluster, has one of the highest girl school dropout rates in the district, a number the rapid arrival of industry has not yet moved. So, what is Sanand? We have been to 2 facilities. We have been to Keynes, we have been to CG Semi. But, like I said, these are OSAT facilities. This is where the packaging and the testing happens. We still import the chips from places like Taiwan and Korea. And we don't really know where we are headed from here, even though Sanand is just the beginning. There is, of course, Dholera, a few kilometers away from Sanand, where the Tata's fab unit will come up in a few years. So, area has already been earmarked. But there are several questions that remain unanswered. First, will we always depend on, these kind of places like Taiwan and Korea, which have spent decades giving pushing money into the semiconductor industry to build semiconductor chips? And will we be the finishing shop of the world? Or will we actually be able to land on our own feet, especially given the geopolitical tensions and conflict that we see? Behind me, you can already see people taking breaks from their factory shifts. It's almost afternoon, it's almost lunch break, the time I'm speaking in. But like I said, all these questions do remain. We are good at packaging, we are good at testing. You already saw the clean rooms, you already saw the kind of workforce, the talent that is being built here. But the senior team still comes from places like Malaysia, Philippines. The talent still comes in from there, and they are the ones handling our workforce. That is not to say that things haven't begun. Things definitely have begun in Sanand, in Dholera, in Gift City, and all over India, in other several places as well. I'm Vrinda Tulsian reporting in Sanand for ThePrint.